Welcome to section 4.8. This is the quadratic formula section, and this is probably the one thing that you remember the most from Algebra 1. Your Algebra 1 teacher may have sang a song for you. Don't expect it from me, but if you know the song, you can, I think, probably make sense of this section a little bit more. What we're trying to do is find equations or find solutions to a standard form equation if it's not factorable. So if we're looking for the value of x, we can use this formula. It's the opposite of b plus or minus the square root of b squared minus 4ac all over 2 times a. Now, biggest thing as you're going through, the equation must equal 0 in order to start using the equation. Okay, so they're going to give you an a, b, and c somehow, and when they do that, then we're going to start plugging this in. So here we go. They give you x squared plus 7x minus 6. It equals 0, so we know we can actually start. As we're doing this, let's talk about what is a. A is the number in front of x squared, which is 1. B is the number in front of x, which is 7. And c is the constant number, which is negative 6. So, let's plug these in. X equals the opposite of b, so it's a negative 7 plus or minus the square root of 7 squared minus 4 times a, which is 1, times c, which is negative 6, all over 2 times a, which is 1. Okay, let's try this again. So we start simplifying. Negative 7 plus or minus the square root. Now here's what I'm going to suggest. 7 squared is 49 minus 4 times 1 times negative 6 is a negative 24 all over 2. And I do it this way because I want it in pieces. So I look at this and I say, well, subtracting a negative means add a positive. So I have negative 7 plus or minus the square root of 73 all divided by 2. Now, 73 is something that we're going to try and break down like we did in section 4.5. Now, the problem is 73 can't be divided by one of those perfect squares like 1, 4, 9, 16, 25. And so, we're looking at these two answers. The problem is we don't know exactly what they look like. So if I were to ask you for exact answers, you would have two. The first one is negative 7 plus the square root of 73 all divided by 2. Or the second one is negative 7 minus the square root of 73 all divided by 2. Now, as you look at this, these are the answers I am going to expect probably 9 times out of 10. If you look at this though and you say, well, I have to graph it, then change these to decimals to be able to graph, okay? So as you look at this, we got two solutions, okay? And as you look at it, if you look at your square root, we had a square root of 73, so our square root was positive, and we ended up getting two solutions. Now, I'm sure you're going, what in the world is she talking about? That's going to come up later, so I want to be able to discuss it. Okay, next one. Let's try again. We first need to set this equal to 0, so I'm going to move this negative 8 over. So I have 2x squared minus 8x plus 8 equals 0. Okay, now, I'm going to stick this in the quadratic formula, but I would suggest until we get good at this, we say that a is 2, b is negative 8, c is a positive 8. Okay, here we go. X equals the opposite of b. Well, b is already negative, so that makes it a positive 8 plus or minus. I take negative 8 and square it. Now, you'll notice I put that in parentheses. That's pretty important going through. Minus 4 times a is 2 times c is 8 all over 2 times a is 2. So I look at this and I say, okay, a plus or minus, well, negative 8 squared, when you square a negative, it turns to a positive 64. 4 times 2 times 8 is also 64, all divided by 4. So I'm going to move this up over here. So what I have then is 8 plus or minus the square root of 0 all over 4. Now, the square root of 0 is just 0. Okay, so I don't really need to add or subtract 0 to this, so I'm going to get rid of it a minute. What I have then is 8 over 4, which is just 2. Now you'll notice I had one solution, okay, one answer, and that happened when my square root equaled 0. Okay, so when my square root was positive, I had 2 answers. When my square root is 0, I had 1 answer. Okay, let's try another one. I'm again going to make this equal to 0, so I'm going to move the 5 over. So I have negative x squared plus 2x minus 5 equals 0. So a is negative 1, b is 2, and c is negative 5. So let's plug it in our quadratic formula. X equals the opposite of b, so negative 2, plus or minus the square root of b squared, so 2 squared minus 4 times a, which is negative 1, times c, which is negative 5, all over 2 times negative 1. So I start working with this, negative 2 plus or minus. Now I suggested you do your squared first. 2 squared is 4, minus 4 times negative 1 is negative 4, times negative 5 is positive 20, all over negative 2. So I have negative 2 plus or minus the square root of negative 16, all divided by negative 2. Okay, let me walk back through and let's talk about section 4.6. When we said we had a negative underneath the square root, we could bring up the square root of the negative 1 and then the square root of 16. The square root of negative 1 is just an I, and the square root of 16 is 4. So I'm going to move this over a second. I have negative 2 plus or minus 4i all divided by negative 2. Negative 2 divided by negative 2 is 1. 4i divided by negative 2 is negative 2i. Now, you'll notice I kept the plus and minus, but I want to just kind of discuss this briefly. If I look at this, I have 1 plus a negative 2i, and I have 1 minus a negative 2i. Well, what does that end up being? 1 minus 2i and 1 plus 2i. So I could just write my answers as 1 plus or minus 2i. Okay, now let's discuss what happened. We had a negative square root, and I'm going to shorthand this a minute. You had a negative square root, which means I had 2 non-real solutions. Or I believe your book calls them imaginary solutions. Imaginary. Okay. So as you're going through, keep that in mind. Okay. Now let's flip to the back side and let's look at one more and then discuss, kind of sum it up as we're going through. All right, one more. All right, 2x squared plus 12x equals negative 16. So let's add 16 to both sides. 2x squared plus 12x plus 16 equals 0. Then we know that a is 2, b is 12, and c is 16. So x equals the opposite of b, negative 12 plus or minus the square root 12 squared minus 4 times a times c, all divided by 2a. Okay, so negative 12 plus or minus the square root. 12 squared is 144 minus 4 times 2 times 16 is 128, all divided by 4. So we'll simplify some more. Negative 12 plus or minus, I've got the square root of 16, all divided by 4. Now the square root of 16, that's just 4. So when I look at this, I have negative 12 plus or minus 4 divided by 4. You can look at this in a couple of ways. I think the easiest way is to break this apart at this point in time. You could say negative 12 plus 4 divided by 4 and negative 12 minus 4 divided by 4. Negative 12 plus 4 is negative 8. When you divide it by 4, you get negative 2. That's one solution. The second solution, negative 12 minus 4, is negative 16. When you divide it by 4, you get negative 4. So you're again looking at two solutions. And you could find these again are x-intercepts on your graph, easily graphable and go through. Okay, now let me reiterate this idea. This idea of a discriminant basically says what happens under your square root. Okay, so what type of number do you get underneath your square root? If it's positive, then the equation has two real solutions. They could be decimals, they could be fractions, they could be whole numbers, but they are actually graphable. So therefore, you have two x-intercepts. If it equals 0, which we had in example 2, then there is one real solution, which means basically it crosses the x-axis once. Normally that happens when it touches, but we'll kind of look at that too. The last one is what happens when it's negative. You have two imaginary solutions or non-real solutions. And basically that means there are no x-intercepts. You can't see them because they are imaginary solutions. Okay? Now, what I want to do is just reiterate the fact that you can tell how many solutions there are just by looking at the discriminant. So if I look at the first one, I only have to do what's underneath the square root. So 6 squared minus 4 times 1 times 5. And 6 squared is 36 minus 20 is 16. What I know from that is that there are two real solutions, and I should do the quadratic formula to find the answers. Okay? In the second one, 6 squared minus 4 times a times c, you end up getting 0. I again know that there is one real solution, but without doing the quadratic formula, I don't actually know what x equals. The last one, 6 squared minus 4 times 1 times 13, I end up getting negative 16, so I know I'm going to have two imaginary solutions, which means my solutions are going to have i's to them. Now, I don't know what they are, but somewhere in there will be an I. Okay? So before you start a question, you could check its discriminant, which you'd want to know that b squared minus 4ac, and that can tell you, is it worth doing the quadratic formula, or is there an easy way to like factor it, something like that. Normally when you have one solution, it's normally easily factorable, and it has something to do with perfect squares. Okay, that's just a little hint going through, but that's the end of section 4.8. That's the last video we're looking at in chapter 4. So make sure you've finished up all your homework and that you're ready to ask questions on the quadratic formula tomorrow.